we are at 1.4 proportional relationships. Okay, so let me give you an example here of proportional relationships. Proportional relationships are basically we like them because the numbers work out well, and we're comparing two things, right? We're comparing, like time and money or something like that, and we want to know if it's going up by the same amount each time. If one goes up, did the other one go with it? Or do things change? Can we predict what's going to happen? Is kind of a good way to think about it. So that's kind of what we're doing here today. Is we're kind of looking at that. And we're saying, okay, how can we predict what is going to happen using our knowledge of proportional relationships? Okay, so let's see here. Okay, so let me give you an example. Don't write this down. Just watch. All right. So let's say, for example, okay, you had a job. All right. You have a job and you get paid money for how much time you work. So if you work 1 hour, you get $18. Pretty good job. If you work 2 hours, you get 36. If you work 3 hours, you get 54. And if you work 4 hours, you get $72. All right. So the question is this relationship proportional? And again, you don't have to write this down. This is just an example. Well, the way we see if it is proportional or not, right? Basically, proportional again means that the unit rate is the same. The rates go up the same way for both the money and time in this case. So what we're going to do is we're just going to put and see if the unit rates are actually equal. And if they are, then it's what we call proportional. So for example, 18 over 1 is 18 over 1. This one is 36 over 2. If we simplify it, divide by 2 top and bottom, we get 18 over 1. If we do 54 over 3 and we simplify that, we get 18 over 1. And if we do 72 over 4, we get the same thing, which is 18 over 1. So it seems really simple, but this right here, if we get 18 every time, then we would say, yes, it is proportional. Okay? Oh, sorry, let me fix that. Can you guys hear me still? Yes? Okay, good, thank you. Sorry if it bugs a little bit. Okay, so again, we can say that this is what we call a proportional relationship. As the money goes up, as the time goes up, so does the money, right? It goes up at the same rate. Now, it doesn't work like that every time, and you will see examples of that as we go. Okay, so here we go. Let's go ahead and do some problems that we're going to put in here. All right, so let's go ahead and let's do a problem here. Letter A. Let's say that at Muscatel, go and copy this down. Oh, that was sloppy, sorry. At Muscatel, there are 2 teachers for every 56 students. Is this a proportional relationship? Okay, I'll give you some time to write that down real quick. Okay, so we want to know, is this a proportional relationship between two things, right? We're comparing teachers and students. And some of you might think, well, yeah, this is easy. And some of these are pretty straightforward. So what we're going to do is we're going to put it in a table. So in the homework today, you're going to see a lot of tables, right? And you're going to have to kind of interpret the data from those tables. Okay, sorry, I'll give you guys a few more seconds here. Okay, so here we go. So let's go ahead and put this in the table. Okay, students, and it doesn't matter which way you make this table. I'm going to do it students on top, teachers on bottom like this. If you want to do it vertical, you could do it vertical instead. So if you rather you want to do it like this way, students and teachers, and do it this way, that's the way you make the table doesn't really matter. Okay, so if there were two teachers, it says if there are two teachers, there are 56 students. Well, what if there were 4 teachers, right? Let's think how many teachers we would need. Well, we doubled this up, so we should probably double this one up. 56 and 56, 50 and 50 is 100, 6 and 6 is 12, so that would be 112. And let's double that again. Let's say there were 8 teachers at Muscatel, which there are, at least. Go ahead and fill in the blank there of how many students that would be. All right, so that'd be, I believe, 224. Okay, so the question is this. The question is this a proportional relationship, right? And the way you answer that question is, are all the ratios the same? If the answer is yes, then it is proportional. If the ratios are not the same, then the answer is no. Okay, so let's take a look. Are all the ratios the same? Let's take a look here. All right, so the first one is 56 over 2. So I'm going to say, okay, 56 over 2, and I'm going to simplify that to, I think I can divide it by 2, and I get 28 over 1. Okay, so now I have to test each other ratio to see if I get 28 over 1. If I do, the answer is yes, it's proportional. If I don't, I say no, it is not. Okay, so, and you can use your calculator here. That's a good, use your calculator. So let's try this one. 112 over 4. Go ahead and put that in your calculator, or you could probably figure that out using just reducing your fraction. Does that come out to 28 over 1? Yeah, Justin says yes. Good, yes. I guess Maria's saying yes. All right, 28 over 1. Okay, so far so good. So this is good, and this is good. Now we have to test every single one. Okay. 224 over 8. Go ahead and try that one out. Two 24 over 8. Did we get 28 over 1? Yeah? Okay. And here's the beauty of this. It actually doesn't matter which one you put on top. If you did teachers over students, you would just get 1 over 28, as long as it's all the same. So look, 28 over 1, 28 over 1, 28 over 1. That's what we call the constant of proportionality. That means with the same ratio every time. So the answer is, the question is this a proportional relationship? The answer is yes. Yes, I'm excited. Yes. Right? because all the ratios are the same. And here's the thing, on your homework today, there are only two answers that you're going to put. It's either yes, the ratios are all the same, or no, the ratios are not all the same. That's it. It's either yes, the ratios are the same, or no, the ratios are not the same. Those are the only two answers that you could put on your homework for the most part. Now you have to show the work, of course, but it's it. It's either yes or no, right? It's just like right now. You right now are either sitting or you're not sitting, right? All of you are sitting. Good job. Okay. There's no in between. It's one or the other. It's yes or it's no. Okay. It's not, well, it's sort of proportional. No, it's either yes it is or no it's not. Okay. All right, let's do another example here. My ruler. Okay, here we go. Oops, I missed a little bit. It's okay. All right, so let's see, letter B. Let's say you're going to go to a school show, school play, and a show costs $7 per ticket. Plus a $3 one-time fee. Is this one proportional? Go ahead and write that down. All right, so you're going to go to a show, so it costs $7 per ticket. But you'll see this actually when people order things online, right? Like it's a one-time fee. So you have to pay for that one transactional fee, but the tickets all cost the same amount. So this is a little bit tricky here, okay? I'll give you guys a few more seconds to write that down. But I'm going to make a little chart, and this time I'll make it vertical. So this is tickets, and this is money. That line was kind of funny. All right, so let's do the math here. If I was to buy one ticket to this show, just one ticket, put in the chat, how much would it cost? Just type in the chat, what do you think, how much would it cost for one ticket? All right. Anthony says 10. 10, yep, 10. All right, $10, good. Okay. Now here is a little bit tricky. How much does it cost for two tickets? Put in the chat, how much do you think it costs for two tickets? Okay, I'm getting a couple different answers here. Some people are saying 14. Some people are saying 20. Some people are saying 17. Okay, so here's the correct answer. We have to think about it, right? One ticket costs 7. Two tickets cost 14. But remember, there's a one-time fee. Well, you only have to pay it once, right? It's not like each ticket is $7 and the $3. So it's not 20. The answer is actually 17. Ah. Okay, so then in that case, how much would 3 tickets cost? What do you guys think? You put that in the chat. Okay, now we're getting it. Yep, we're getting it now. Okay. Yeah, now it would cost $24. Very good. All right. So again, you have to remember that $3 fee. So it's each ticket is $7. So 3 times 7 is 21, but $3 for the fee. And again, you see that all the time when people buy things online now. Like you don't have to pay shipping on every item if you buy something online. Like if you go shop online and you buy 5 things, like it's not like each thing has its own shipping cost, right? It's like one cost for the shipping. Okay. And if you go over a certain amount, maybe you get free shipping. But right, it just because they're all going to put it in one box, so you only have to pay the shipping for one thing. That's what's going on here. Okay, so the question is this proportional? Okay. I had a question about how to get 17. So let me go over that again really quick. Okay. So $7 per ticket, right? So one ticket costs $7. So I'll break it down. So this one is $7 plus the $3 fee. This one is 2 tickets. So 7 plus 7 plus that fee you only pay one time though. You don't pay for it for each ticket. And this one would be 7 plus 7 plus 7, 3 tickets plus the one-time fee. Is that clear? Clear as much? Okay, so the question is this a proportional relationship? Right? So let's take the ratios here. So money over time, money on top. So let's do the first one, 10 over 1. The second one, is this equal to 17 over 2? Are those equal? No, right? 17 over 2 does not simplify to 10 over 1. These are not equal. So the answer to your question is this proportional? The answer is no. The ratios are not the same. Now you might be asking yourself, Mr. Leong, but don't they both all go up by 7? Is that what this is about? It's not about them going up by the same amount. It's about their ratios, their unit rate being the same. Okay. So if I am going to pay for 10 tickets, I can't just say that $70. It's not like that. Right? We have to know that everything is a little bit more. Okay. So the answer to this question is no, the ratios are not the same. And the cool thing about the one where they're no is the best thing about it is that if it's no, you know right away, right? And you don't have to check every single one. Like I didn't have to worry about the 3 and 24. Okay. Instead, as soon as you know something's wrong, then that's it. It's done. Okay. So it's kind of like when you guys are talking to your parents and your parents say, you know what? You never take out the trash. And all you have to do is say, wait a second, Mom. Remember 3 weeks ago? I took out the trash 3 weeks ago. So you can't say never, right? All you need is one little counterexample. That's it. One thing to say, nope, that's not true. And the whole thing is false. Okay. So if you look at these 2 examples, okay, letter A, yes, the ratios are the same. They're all 28 over 1. And on letter B, no, they're not the same. And all I'm doing is making a fraction out of these numbers. That's it. And I'm just seeing if the fractions are the same. If they're the same, then we're good to go. If they're not, then the answer is no. Okay. Okay. Let me give you one to do on your own, and that'll be kind of like the end here. Just one real quick one. All right. Letter C. Let's say you're going to make some muffins. And you need cups of water for every thing of mix. Okay. So let's see. How about this? 1/2 over 1. 1 cup, need 2 boxes of mix, and 1.5 and 3. Okay. Can you tell me if this is proportional or not? Go ahead and figure it out. Ooh, fractions. Fractions on top of fractions. Oh no, do I remember how to do that? I sure hope so. Give it a shot. right, give you guys another minute here. All right. By show of thumbs, thumbs up or thumbs down, proportional or not? Give me a thumbs up if you say yes, a thumbs down if you think no. What do you guys think? Yes or no? All right. Benjamin says yes. Edgar says yes. Joaquin says no. Matthew, I think, says yes. It's kind of sideways. Okay, it's up. Good. What do you guys think? Up or down? Yes or no? Nathan says yes. Derek says yes. Allison says yes. So does Ida. Jen says yes. Okay, let's check it out. Here we go. So I'm going to look at this. I'm going to do the ratio. I'm going to do cups to mix. Okay. So 1/2 over 1. That one's easy. Anything divided by 1 is just the same thing. So I know that simplifies to 1/2. Okay, this one. 1 over 2. So 1 over 2 is 1/2. So far, so good. All right, now this third one. 1.5 divided by 3. Okay, now we got to do a little bit from what we did last lesson, complex fractions. So here we go. I'm going to change that to rewrite 1.5 divided by 3 over 1. I'm going to change that to an improper, which is 3 over 2 divided by 3 over 1. Then I do the reciprocal, which is 3 over 2 times 1 over 3. 3's cancel. Get a different color for you guys. 3's cancel out. So what am I left with? 1 times 1, which is 1. 2 times 1, which is 2. Check it out. 1/2, 1/2, 1/2. Yeah? So are all the ratios the same? Yes. Is it proportional? Yes. The answer to this one is yes. All the ratios are the same. Okay? So that is what you need to do on tonight's homework. That's what it is. Proportional versus non-proportional. Are the ratios the same? Is it going up by the same amount each time? So as one goes up, the other one goes up with it. As one goes down, the other one goes down with it. Kind of like it's going in parallel with each other. That's what we're trying to figure out, okay? So that's all you have to do. I know it's a little bit of work. So again, if it is, you have to do all of them. So notice I had to go all the way through. If it's not, you just say, nope. As soon as you see that it's not, then it's gone. Done. Don't even worry about it.